The next topic is division by radicals. Division by radicals means that the divisor, or denominator when expressed as a fraction, contains a radical expression. Written as a fraction, which implies the operation of division, the objective is to end up with a fraction with a denominator that is radical free. When you have met this objective, you have performed the operation of division by a radical expression. When the denominator is the process of having the radical eliminated, we refer to this as rationalizing the denominator. The process of eliminating the radical from the denominator is called rationalizing the denominator. Once you have established the radical-free denominator, you have completed the operation of division, as I have said. If the square root of 3 is in the denominator, for example, then can perform an operation such as the square root of 3 multiplied by itself eliminates that radical. It seems then, for a single radical term, that if you multiply that radical by itself, you will be rationalizing the denominator. Here is another example. Suppose in the denominator you have 2 square root 3. If you take 2 square root 3 and multiply it by square root 3, you'll end up with 3 times 2 is 6. No radical in that expression. Each of these 3's which I've used in order to convert a radical expression into a radical-free expression is referred to as a monomial conjugate radical. The square root of 3 is a monomial conjugate radical. The conjugate radical is used to produce a radical-free expression, where we're dividing by a monomial. Remember that you can think of a fraction as being a division problem, and the denominator is similar to a divisor, therefore. We have, as our example, the square root of 3 divided by the square root of 2. Now recall, division is not complete unless the denominator is radical free. In order to get rid of the square root of 2, we must multiply the square root of 2 by its monomial conjugate, which is the square root of 2 again. The square root of 2 is the conjugate. But if you're multiplying a fraction by another fraction and its value is not to be changed, then the fraction you're multiplying it by must be equal to 1. You must multiply by the square root of 2 over the square root of 2. When you are done with this calculation, the square root of 6 over 2 is the completed version of the problem. For another example, let's take the square root of 5 minus 2 times the square root of 2 over the square root of 3 root 2. Now, notice once again that I have a single radical in the denominator, 3 root 2. The conjugate to 3 root 2 is root 2. And to get rid of the radical in that denominator, I must multiply by this conjugate. I'm going to multiply by a fraction containing root 2, both in the numerator and in the denominator, so that when I'm multiplying this out, which amounts to multiplying by 1, I'm not changing the value of the given fraction. Continuing then, I have the square root of 2 multiplied by this term and the square root of 2 multiplied by this term. This amounts to root 2 times root 5 is root 10. Root 2 times 2 root 2 is equal to minus 2 root 4, careful here, divided by 3 root 2 times root 2, which is 3 times 2, and that is equal to, the denominator is radical free, and we have completed the division as required, but we still have to do a bit more work and simplify this part of the expression. So we are not done until we do that, and the final answer is the square root of 10 minus square root of 4 is 2. 2 times 2 is 4, so we have minus 4 all over 6. Here's another example. I will use a different index. The cube root of p squared q squared divided by cube root of p to the 4th q squared. There are several ways that we can proceed with this solution, but let's do it this way. Since the indices here, plural indices, singular index, since these indices are identical, recall in an earlier statement that I can write the entire radical once with the radicands placed within it. This immediately shows up one interesting, important aspect of this problem, that q squared over q squared can be taken right out since they are equal to each other. P squared over p to the 4th can also be simplified, and what we end up with is the cube root of 1 over p squared. The solution is not completed, but at least for now, the radicand is a simpler version of the problem that we started with. This is equal to 1 over the cube root of p squared. Notice that this is not radical free in the denominator. Consequently, division is not completed. How much would I have to multiply the denominator by in order to make it radical free? In other words, How much would I have to multiply the denominator by in order to rationalize it? The amount is the cube root, I should say, of p. The cube root of p squared times the cube root of p is the cube root of p cubed. And the cube root of p cubed is a rational number. But, of course, we have to write the cube root of p up here as well. Make sure this fraction is equal to 1 before we can continue. 1 times the cube root of p, then, is the cube root of p over, careful now and follow this thoroughly. The cube root of p squared times the cube root of p can be brought together under one radical, which is the cube root of p cubed. But the cube root of p cubed is simply p, and there you have the solution completed. So the final answer here is equal to cube root of p over p. The next kind of problem dealing with division will be by a binomial. That is, of course, a binomial radical expression. To rationalize the denominator of a binomial radical, multiply the numerator and denominator of the given question by the radical conjugate of the denominator. The radical binomial conjugate of the denominator. To rationalize the denominator, multiply by a fraction equal to 1 made up of the binomial radical conjugate of the denominator. Let's take a binomial radical expression and determine what its conjugate is. I'm not going to deal with the division of a binomial radical yet. I will do that later. I'm just concentrating on the conjugate itself. Let's take 2 minus the square root of 5, and that is supposed to be the radical in the denominator of a fraction. What would we have to multiply 2 minus the square root of 5 in order to remove the radical sign? Recall in a tape on factoring that a minus b times a plus b is equal to a squared minus b squared. Of course, the order of these two binomials will not make any difference. But that's the key to the answer to the question I posed earlier. What shall I multiply this binomial radical by in order to eliminate the radical sign? Well, the answer lies in understanding this. It goes like this. 2 minus root 5 multiplied by 2 plus root 5 is equal to, follow the pattern of this expansion, must be a squared, and this is where a is, and so 2 times 2, or 2 squared, is 4. The rest of it contains a minus sign followed by b squared, or b times b. But that is square root of 5 times the square root of 5 is the square root of 25, and the square root of 25 is 5. So there you have something that we started with a radical in it reduced to a radical-free quantity. And that's how you rationalize denominators of a division problem involving radicals. So that the fraction that we're looking at equal to 1 is made up of such a combination of terms in the numerator and in the denominator. For example, divide 3 by 2 minus the square root of 5. The conjugate radical of 2 minus root 5 is 2 plus root 5. So therefore, multiply by a fraction equal to 1, made up of those numbers. There they are. Well, we've already done the denominator, so we know what that is equal to. It's equal to minus 1. It's radical free now. But the top part has to be expanded. 3 multiplied by 2 is 6. 3 multiplied by plus root 5 is plus 3 root 5. We don't want negative signs in the denominators, and so we will divide this out and give as a final answer minus 6 minus 3 root 5.